and our topic was discrete cosine transform DCT. And my groupmates was Ishwar Deshpande, Abhishek Patil, and myself. Next slide. Sir, here are our some outlines of project. In this project, we discuss some introduction, transform coding, mathematical basis, properties of DCT, limitation of DCT, references, and comparisons of DFT, and so on. Next slide. Sir, here is our introduction of PPT. In this PPT, we introduced the DCT has emerged as the image transformation. As we all know, the DCT with the help of DCT, we want to immerse the image transformation is most in most visual systems. DCT has been widely developed by modern video coding standards, and it has some base of MP, EG, and JVT, etc. It is the same family of the Fourier transform. At it has been come in the Fourier transform family, and it converts data to frequency domain. It represented data simulation of variable frequency cosine wave. So our data simulation of frequency is represented by variable frequency of this DCT image transformation, and it also captures only real components of the functions. Now, next slide will be present by Ishwar Deshpande. Thank
Thank you, Yash. Here are the basic mathematical of the DCT. As Yash said that the DCT is a discrete cosine transform, helps to separate the image into the parts spectral subbands of different importance with respect to the image visual quality. Here is the DCT encoding. The basic operation of the DCT is as follow. The input image is by n by n. The f of ij is the intensity of the pixel in row I and column j. The f of u and v is the density coefficient in row k1 and column k2 of the density matrix. Here are two different densities. The first is 1D density. The formula is C of u is equals to alpha of u summation of n minus 1 x is equals to 0 f of x cos pi in bracket 2x plus 1 divided by 2n. Alpha of u is equals to square root of 1 by n for u of 0 and square root of 2 by n for u of u is not equal to 0. The second formula was 2D for DCT. Here is a summation of n minus 1 x is equals to 0 and summation of n minus 1 y is equals to 0 for cos pi in bracket 2x plus 1 divided by 2n cos pi in bracket 2y plus 1 divided by 2n. Here is what is the transform coding. The transform coding is the function which gives known as array size 8 into 8 can be pre-computed and stored. It involves simply computing values for a convolution mask 8 into 8 window, and that get applied to sums value into pixel values windows overlap with the image apply windows. The transform coding constitute an integral component of contemporary image video processing applications. The transform coding realize the premise the pixel and the image exhibit a certain level of correlation with their neighboring pixels. Similarly, the video transformation system adjacent pixel in consecutive frames show very high correlation. Consequently, this correlation can be exploited to predict the value of a pixel from its representative neighbors. As it is computationally easier to implement and more efficient to regard the DCT as set of basic functions. Transformation is a lossless operation, therefore, the inverse transformation readers a perfect reconstruction of the original image. Then I will hand over the next slide to the Abhishek Patil.
Okay, thank you, Shri. And next slide is why we transform coding. So basically, why we transform coding for better image processing, fast computation, alternative representation and sensing, efficient storage and transmission. Next slide, please. So next slide is the property of DCT. There are basically five types of property of DCT. First is de decorrelation, energy compression, separability, symmetry, and orthogonality. Next slide, please. Next slide is a comparison to DFT. As compared to application of DCT results in less blocking artifact due to event symmetry extension property of DCT. DCT uses real computations unlike the complex computations uses in the DFT. DFT is a complex transform and therefore stipulates that both image magnitude and phase information be encoded. DCT hardware is simple as compared to DFT. DCT provides better energy compression and DFT for most natural images. Next slide, please. Next slide is the limitations of DCT. There are basically three types of limitations. Uh, Truncation of higher spectral coefficients result in blurring of images, and especially whenever the details are high. Coarse quantization of some of the low spectral coefficients introduces graininess in the smooth portions of the images. Third one is a serious sorry. Third one is a serious blocking. Artifacts are introduced at the block boundaries since each block is independently encoded, often with a different encoding strategy and extent of quantization. And there are some references which we use in our PPT. And thank you.
Thank you so much, sir.